Today, I'm going to discuss adversarial machine learning. With the explosion of AI, generative AI, and LLMs, we need to consider how AI models can be exploited and how we need to take action to protect those models. Let's dig in. Adversarial machine learning is a fascinating, crucial field that explores the vulnerabilities of machine learning models and methods to exploit them. In essence, it's a two-sided coin. One side, attacks. This involves crafting malicious inputs called adversarial examples that deliberately trick a machine learning model into making incorrect predictions. These attacks can have serious consequences ranging from fooling facial recognition systems to manipulating search engine results. On the other side, there's defenses. Researchers and developers are constantly building defenses against these attacks. These involve techniques like training models on adversarial examples, exposing models to carefully crafted adversarial examples during training can help them become more robust and less susceptible to future attacks. Also, developing detection algorithms. Techniques are being developed to identify and flag adversarial examples before they can cause harm. Improve explainability. By understanding how models make their decision, it becomes easier to pinpoint vulnerabilities and build better defenses. White Box Evasion Attack. Think of a clever thief who figured out how to pick your fancy high-tech lock. They used tiny tweaks, invisible to most, to bypass the security and sneak in. That's kind of like a white box evasion attack in machine learning. Machine learning models are like those advanced locks learning to recognize things like pictures or voices. White box attackers understand the model's inner workings, like the lock's blueprint, and craft special inputs like the tiny tweaks that trick it. These adversarial examples might be slightly altered pictures, seemingly harmless sentence, or a near-perfect voice recording. They fool the model into making mistakes, like thinking a cat picture is a dog. It's a sneaky way to break the security. But researchers are constantly building better locks to keep our machine learning models safe from these clever attacks. Even though white box attacks sound scary, there are ways to fight back. Here's some tricks we use to keep machine learning models safe. Training on adversarial examples. Imagine exposing the lock to fake keys to learn how to resist them. We can train models on these specifically crafted bad inputs so they recognize and reject similar tricks in the future. Adding randomness. Think of making the lock changes combination every day. Introducing randomness in how the models make decisions makes it harder for attackers to predict and exploit specific weaknesses. Monitoring and detection. Just like checking the lock for signs of tampering, we can monitor models for suspicious behavior and unusual outputs. This can help us catch potential attacks before they cause harm. Black box. Imagine Robert trying to fool a high-tech vending machine, but they're blindfolded. They poke at random buttons, hoping to snag the wrong snack without ever seeing the machine's inner workings. That's kind of like a black box evasion attack in machine learning. Our trusty models are like those vending machines trained on data to make decisions. Black box attackers craft special inputs, the button presses that fool the model without needing to know how it works. These adversarial examples might be slightly changed pictures, subtly tweaked emails, or even distorted sound recordings. To us, they're normal, but to tricked model, they're like magic buttons triggering the wrong output. It's sneaky and powerful, but researchers are constantly building better blindfolds for attackers, making it harder to fool these models without knowing their secrets. Even though blindfolded attackers sound daunting, there are some ways to keep our machine learning models safe. Here's some tricks we can use. First, detect algorithms. Think of guard dogs sniffing out hidden treats. We can build smart systems that scan inputs for suspicious patterns, even if they look normal on the surface. Defense in depth. Imagine layering security measures like a fortress. By combining different defenses like adding noise or random changes to data, we can make it harder for attackers to find a single magic button. And of course, collaboration and research. Just like sharing security tips with neighbors, researchers worldwide share knowledge and develop new defenses. This constant vigilance helps us stay ahead even in the craftiest blindfolded attackers. Availability poisoning attack. Imagine learning all about healthy eating from a cookbook, but someone snuck in fake recipes with spoiled ingredients. Your cooking would go downhill fast. That's like an availability poisoning attack in machine learning. Machine learning models learn from data to make decisions, like recognizing emails or filtering spam. Availability poisoning attackers sneak in poison data, like the fake recipes that messes up the model's whole learning process. This bad data might be slightly altered pictures, manipulated text, or even fake sounds. It's like learning from bad cookbooks. The model becomes unreliable and makes bad decisions, potentially putting all of us at risk. But just like we have food safety regulations, researchers are working hard to identify and remove poison data, keeping our machine learning models healthy and reliable. Even though poison data sounds scary, here's some ways to keep our machine learning models healthy. Here's some tricks. Data cleaning. Imagine washing the bad fruit before cooking. We can scan data for suspicious patterns and remove poison samples before they mess up the model. Robust training. Think of giving model extra practice against tricky recipes. We can train models on diverse data and even poison scenarios so they become less fooled by real attacks. And then monitoring and detection. Just like checking the kitchen for spoiled food, we can monitor models for unusual behavior and suspicious outputs. This can help us catch potential poisoning attempts before they cause harm. Targeted poisoning attacks. Imagine you're at a beautiful garden. Everyone is enjoying the delicious food and flowers, but someone slipped a special fertilizer into your friend's plate, making their food taste awful. That's kind of like targeted poisoning attack in machine learning. Our amazing machine learning models are like those gardens, learning from data to make decisions, like identifying faces or recommending movies. Targeted poisoning attacks are like the sneaky fertilizer spreader, but instead of targeting everyone's food, they aim for specific victims. They inject poison data, think a special fertilizer, into a training mix, but for only data related to their target. This poison data might be slightly altered pictures of your friend, manipulated text mentioning them, or even fake voice recordings. It looks normal on the surface, but for the model, it's like a hidden toxin influencing the decisions only when encountering your friend. Think of it this way. If you have a facial recognition system at your door, targeted poison attack might involve feeding it altered images of your friend that makes the system think it's a stranger, denying them entry. Scary, right? That's why researchers are developing ways to clean the garden and remove targeted poison before it can harm specific individuals. Remember, even though these attacks sound alarming, experts are protecting us. Just like gardeners have ways to identify and remove harmful plants and pests, researchers are building tools to help keep our machine learning models fair and unbiased. Backdoor poisoning attack. Imagine you have a beautiful automated greenhouse taking care of all of your plants, but someone stuck in a tiny device on one specific rose, giving them a hidden control switch. That's kind of like a backdoor poisoning attack in machine learning. Our trusty machine learning models are like those fancy greenhouses, learning from data to make decisions like recognizing cars or translating languages. Backdoor poisoning attackers are like the sneaky device installer, but instead of targeting every plant, they only focus on specific ones. Think like our rose. They embed hidden triggers like special patterns or codes in the training data for their target. These triggers act like a control switch, allowing the attacker to manipulate the model's output later, just like flipping a switch to make only the rose bloom at the wrong time. Think of it this way. If you had a loan approval system using machine learning model, a backdoor attack might embed triggers into data for specific applicants, making the model seem unfairly deny them loans. Scary, right? That's why researchers are constantly building better greenhouse security to detect and disable these hidden control switches, keeping our models reliable, trustworthy, and disable these hidden control switches. Remember, although backdoor models seem alarming, experts are actively protecting us, like the vigilant gardeners removing unwanted devices or pests from their plants. Researchers are developing ways to clean data from our machine learning to keep it fair and secure. Adversarial machine learning is about understanding the weakness of AI systems and finding ways to defend attacks that try to exploit these weaknesses. It's like a battle. Remember, it's a constant battle between attackers and defenders. But by keeping these approaches in mind, we can make sure our machine learning models stay vigilant and secure. Thanks for stopping by today. If there are any topics you would like me to talk about in the future, please post it in the comments. In the meantime, everyone, please stay safe and secure until we see you next time.